Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 9C. My name is Siddhi Auti and I'll be your moderator for today's session. Me, on the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trains and Computing and Communication, SMARTCOM 2025. The ninth edition of this conference is being held in a hybrid mode. The physical event was held on 29th January and the virtual event is being held via Zoom meeting yesterday and today. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, in total, we are having 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. After 7 minutes, I will be raising a gentle reminder. Also, there is another request to all the participants that you stay connected with us till the closing remarks. And if you face any issues or queries, you can write it to me in the chat box and our team will be solving those. Now, just before we get started, I would like to introduce you all to the session chair of today's session, Dr. Sopan Tarekar.
Yes, good afternoon, ma'am.
Good afternoon, sir. Dr. Sopan Tarekar is currently working as Associate Professor, Karamveer Advocate Baburao Ganpatrao Thakre College of Engineering, Nashik. He has published and presented more than 10 papers in reputed journals like IEEE, ACM, Springer. He has published two books on artificial intelligence for Pune University and Gujarat Technological University. I welcome you, sir, for today's session.
Thank you.
Now we'll quickly proceed to our very first presenter. So the first paper is a study on automation of traffic violation detection. And this paper will be presented by Kesari Abhinav Reddy from Chaitanya Bharati Institute of Technology, India. I request Kesari Abhinav Reddy, sir, to please proceed with your presentation.
Good afternoon, everyone. So this is Kesari Abhinav from Chhatrapati Institute of Technology, and the work I am going to present today is a review paper published by which I intend to publish at SmartCom 2025. So the title of the piece goes as a study on automation of traffic violation detection. So our abstract is yeah. Traffic violations such as speeding and signal violations, improper parking, and use of mobile while driving, and all those things have been a major problem in road safety. Although there have been many advances in the technology, but the primary way of recording and ticketing these traffic violations has been same over the years. So we are going to study about the major works which have been done in the part of automating the traffic violation detection systems over the years and analyzing their results and their drawbacks. Mm. Over the past 2 decades, due to urbanization, there have been many rapid surge in the number of vehicles running on the roads. As the traffic increases, also the number of violations are increasing. But there is a limit to the workforce which would be working towards the traffic maintenance. So the better option would be to shifting towards the automation of the traffic violation detection and ticketing. But the implementation of these things has been very low over in the current scenario. Um, Coming to a literature survey, we have a we have a paper published in 2002, this is a base paper actually, and the technologies used were YOLO V4 and Tesseract ORC for the optical character recognition, uh, and then deep software tracking of the vehicles. The model attained an accuracy of 90% in real time video analysis, and the traffic violations covered by the model were helmet use, phone use, triple riding, wheeling, and no parking. Uh, the si- the main disadvantage of the model is that it uses YOLO V4, which ca- which, uh, which is a very old model of YOLO family, and it requires a large computational power while working on the real-time scenarios. And then there is a model which was developed for a special case of low light scenarios like night traffic. The model was focusing solely on the performance to get the better performance on low light areas. And the authors used YOLO V8 for object detection and OTS used thresholding for analyzing the darker areas of the image and making brighter pixels. Uh, and the precision and recall obtained were 92.8, 98.2 and 97.5 respectively. And the violations covered here were helmet use, triple riding, wheelies, and stoppies. And the number of the disadvantage of the model is that the model was solely focusing on the night times, and also the traffic violations covered by the model were less. And also, uh, the other one is that the both models were solely focusing on the two wheelers, completely neglecting the three wheelers and four wheeler violations. And the next one is the next model uses YOLO V5 and Strong Sort. Strong Sort is an modified version of Deep Sort which provides us with better results and less computational power. And mobile net was used for ticketing ticketing the violations that were recorded. According to the paper, the accuracy they got was 100%. But the problem here is that the video, I mean, the sample video they use it for the analysis of the model was too short, and it was consisting of only the violations and no the number of non-violators were very low, and the road traffic density was very low in the video. So we can't be saying that the model has a great accuracy just by seeing the video given by them. And then the next model uses the RFID technology for sensing of the vehicles passing through the uh, through the line of the signal. And when the violation is recorded, the tickets were generated. The main drawback of the model is that the model was not tested on the real time scenarios, but it was rather tested with the 3D model created by the authors. Uh, then the next model uses the faster RCNN version of object detection for traffic violation detection. The violations covered with helmet use and signal violation. Uh, the paper, the mentioned disadvantage of the model is that the model highly depends on the models working highly depends on the camera position. If the camera is rotated, or if we are using it for another junction rather than the place from where the data was collected, the accuracy might drop. And then the next paper uses genetics algorithm for object detection and tracking. And the violations covered here were overspeeding and blocking of the pedestrian lanes. And also number plate detection was involved in the model. The accuracy of the model was not mentioned in the results, but uh, the author has modified the genetics algorithm to be better fit for the scenario of traffic violation detection. And coming to the observations from the literature survey and the review we have done, it's that most of the models which have been researched are highly highly lean they highly lean towards the computer vision. Uh, and then and then the IoT is a prosperous technology which might be which would be very useful for a traffic violation detection scenario, but the researchers which have been worked on IoT were very few. It might be due to the small number of violations which can be covered using IoT. And then
Hello.
most of the models.
Sir, sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Okay. So our conclusion ends with giving suggestions for the future works that might be done in this area. The future works might cover the uh, different environmental conditions so that the systems would be working on not only the clear days or but on the rainy days and the foggy days. And also most of the works do not provide an end-to-end system for from the detection to ticketing and providing the traffic challans. It would be a better system if all those things are combined into a single research which could be ready to use work. So in that way I'm concluding my presentation. Thank you.
Hello. Yeah, I am audible.
Yes, sir.
Yes, sir.
Okay. So you have done literature survey on traffic violation rules, right? Using the different algorithms. So I just want to ask you, so different methodology that are used, like genetic algorithm, then CNN is there,
Yes,
then
sir.
YOLO. So if you consider all these algorithms, so computing power, so we can say that which algorithm is best in case of the computing power. If you consider the computing power, how much power is required? So yeah, any literature that we have done on this particular parameter?
So, our work is that we have studied different papers which have been worked towards this thing, and from our observations, I mean, like from our observations and the data we have gathered online, the best algorithm for the real-time scenario is YOLO. Basically, it's due to that YOLO is developed for working in the real-time scenarios where the computational power should be balanced with the accuracy, and the speed is important when working. That's when YOLOs are mostly used. So from our thing, from the research we have gathered, YOLO is the model which would be great for real-time scenarios, which would be providing the speed with accuracy.
Okay, so there are different versions that were used in the existing literature. So version 5 and 8. So how you can differentiate this version in terms of the performance?
Yes, sir. Basically, even by using the different versions, we have seen that older version, some of the in the works, the older versions did get the better accuracy, but we can't be saying that the older versions are better than the newer versions, as the accuracy obtained by the authors would depend on the type of training they have done and also the data they have used. Uh, by if we but in the current scenario, if we train the new versions of the YOLO with better data set, it would actually give the better performance than the older versions. So that's what the conclusion we have got.
So performance is depend on the quality of the data, not depend on the version, right?
Yes, sir.
So that is your opinion.
Yes, sir.
Okay.
It depends on the version too, but quality of data matters the most. If we use the data doesn't cover a large number of prospects, and also the data has there was one model which gave us the 100 which in the literature they said that there was 100% of accuracy with their model, but if we consider the real time scenarios, it won't be it's impossible to get the 100% accuracy with any model. So that's what I'm saying, sir.
Okay. Okay, that's it. Good.
Thank you, sir.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next paper is on a survey on the lung diseases prediction in an Indian environment using machine learning. And this paper will be presented by Industry Shetty from GLS University, India. I request Industry Shetty, ma'am, to please proceed with your presentation.
Uh, Sorry, but I can't present my screen. Yeah, okay.
Ma'am, now you will be able to
Yeah,
present.
yeah. Okay. Good afternoon, panel members. I think my my screen is visible, right?
Yes. Yes.
Okay. Yeah. Good afternoon, panel members and all other presenters over there. Myself, Industri Shetty, presenting this paper with my guide, Prerna Agarwal and Savita Gandhi, Dean of the FCIT, GLS University. Moving ahead, here is the flow for the entire presentation, starting from introduction to chronic respiratory diseases scenario in India. It is basically from 2023 because we have written this paper on 2024. So we have collected the data till 2023. Then we will go for the proposed research gap, conclusion, future scope, and references. So basically, respiratory diseases such as COPD, cystic fibrosis, chronic bronchitis, ILD, pleural effusion, pneumothorax, and mesothelioma have a substantial impact on global health rate and illness, focusing on the impact of early detection.
Industry, sorry for the interruption. Can you make slideshow?
So I think it's okay. Just a minute, sir. So can you see that?
Yes. Yeah, go ahead.
Yes, thank you. Okay, so ML and DL models such as CNN and other advanced architectures uses large data sets of CT scans and X-rays to provide an accurate result, resolving problems in India. Air pollution, smoking, climate changes, and hereditary factors significantly contributes to the growing burden of respiratory diseases in India. Previous study in healthcare using ML LACS focuses on model adaptability. Training on various data sets is needed to adaptability and clinical application. Improving ML adaptability and utilizing various data sets can improve diagnosis for chronic and respiratory diseases with accurate diagnosis. So here is the graph showing the contribution of India in CRD cases as per 2023's data. You can see that 55.23% of COD cases are from India. And asthma cases found in India is 35%. Global CRD rates contributes 15.69% in India. Also, India counts 30.28% of global CRD rates death. So coming to the various lung diseases affecting with percentages. So you can see that COPD with 89%, asthma with 51.30%, lung cancer with 12.70%, cystic fibrosis, it is 0.00135%, and so on. So coming to the comparison table of the detection in the different lung disease in Indian scenario, based on these parameters like disease prediction, data set used, sources of data set, finding limitations, and so on. So just a second. You can see the table, right?
Yes.
Okay. So for this literature review or for this research paper, we have totally collected the data from 16 research papers. From mainly, we have what we have detected or what we have seen is the detection rate, detection of the diseases are COPD, cystic fibrosis, pneumothorax, mesothelioma. These are the 9 diseases actually, and after that we can say the data sets they have used are CT scans and X-rays. Sources are basically from online, or some of them have used like physical hospitals also. For the methods, they have basically used CNN models or deep learning models. The accuracy rate for the accuracy rate, 99.68% is the highest accuracy rate we have taken, which is from the paper number 10th. And for the lowest accuracy rate, it is 80%, which we have taken from paper number 9. So coming to the findings of this, like what we have concluded or what we have found it is the common finding is AI driven models enable fast, accurate, and cost-effective respiratory diseases or diagnosis and classification. For the limitation, the common limitation is limited data, security issues, overfitting, noise, and unreliable accuracy of AI models. And the common future scope is to focus on enhancing model accuracy, expanding data sets, integrating real-time tools, or supporting scalability and improve clinical validations. So coming back to the PPT, just a minute. Okay, so coming back to the PPT, so this is from the previous which we have shown. Here is the final 7 categories of diseases you can see here, which we can explore more with the use of ML in Indian scenarios. So basically, we are going for Indian scenarios. So what we have previously we have seen that for the global scenarios, and now we are going for the Indian scenario. And in Indian scenario, here are the 7 diseases which we can explore more with the help of their categories and subcategories, and we can detect it using ML and DL with the help of images like CT scans and X-rays. So concluding my paper, I can say the study explores ML for lung diseases, diagnostics in India, focusing on advanced classification methods required, early detection, personalized therapy, cost-effective screening of the mobile apps, and genetic predictions, etc. to be used. For the future scope, we can say that early diagnostics leads to early detection, prediction, and cares. Factors like demographic or environmental, such as air pollution, smoking rates, climate changes, weather patterns, and genetic heredity, to be focused on creating models. Managing research gap will result in better outcomes and more suitable healthcare solutions. So here are the references or the paper which we have used for this paper. So thank you.
Thank you,
Okay.
ma'am, for your presentation.
Okay, Hindusri, it was nice survey on lung disease detection, right, using machine learning. I just would like to one question on it. What are the challenges that you have find out throughout this survey? And yeah, continue.
So basically, what we have from the 16 papers which we have read, the basic challenges, or we can say the main challenges, is they have taken a limited amount of data set. Plus, what they have detected is, we can say, the models they have used are not basically they can they can detect only 1 or 2 diseases from any of the data sets, but they don't have, if they are going for more data sets, or if they are they are increasing their data set, then the models are failing or something like that. So that's the main challenges for the data set and the models they have been used.
Okay, what do you think about the deployment of this particular model in case of challenges?
So basically, what we are going to do is taking a large data sets and the original, we can say that the original data sets, or what they have uploaded, whatever. But we are going for the large data sets with the same, we can say, the same model or also, but we are going for the large data sets. So might be, I'm not sure that we are going to do we are like we are going to be successful or no, but we can say that the challenges what they are facing might be like lesser sometimes, or what?
Okay, if you consider the data set, if you talk about the data set and quality of data set, so where the image quality that does the matter, yes, to find out the how to take the performance of that any algorithm, quality
Uh,
of images.
Yes, sir. Quality of images also matters, because if like we can say if one of the images are going to be wrong or something, then it can be harmful, or what I can't say harmful, but the results which we will get will be the false results. That's why.
Okay, okay. Thank you.
Okay, sir. Thank you.
Ma'am, now we'll go on to the next presenter. So the next paper is on development of AI-based fashion recommender system for e-commerce business. And this paper will be presented by Siddhi Mulewar from MIT Academy of Engineering, India. I request Siddhi, ma'am, to start with your paper presentation.
Yes, ma'am. So the title of our presentation is Development of AI-based Fashion Recommender System for E-commerce Business, and our paper ID is 41. So the rise of e-commerce has transformed the retail landscape, and artificial intelligence is taking it to the next level. Today, I'll present our research on developing a fashion recommendation method that leverages deep learning techniques to provide personalization fashion suggestions by harnessing the power of collaborative filtering, ResNet 50 neural networks, and virtual try-on networks. We aim to enhance the online shopping experience, foster user engagement, and promote customer loyalty.
Hello. So we have built this project. We have used an transfer learning system for this project. We have used a pre-trained ResNet 50 model for the feature extraction. So what we did was we already had a data set of clothing images. We use a pre-trained ResNet model, and we extract all the features from that images and convert into a 1D vector, which is then exported into a pickle file, and later it is used for a recommendation process. So, for example, if a customer wants to purchase a product which is not describable and which is unable to describe, and so he or she can put an image into that interface, and then it will recommend you the exact five images which is similar to that product. So we have used Karen algorithm for the recommendation part. Now, why did we choose ResNet 50 model? We did a classification for that as well. We have used Inception V3 model and MobileNet and ResNet 50 model for the better classification, which gives the better accuracy. And it turns out to be that ResNet 50 was giving us the best accuracy on that. Next will be presented by Gauri.
So this was the objective for our project. So to study different recommender system and dataset for fashion recommendation system. So firstly, we searched through what are the basic filtering methods. There were the collaborative which I have chosen for a project. Then we implement deep neural network to classify fashion image dataset. Then we develop the recommendation system, and also we have integrated the virtual try on our project. So to develop AI-based e-commerce web page for fashion recommendation. Next slide. So these are the architecture we use. These are the architectures of the uh, models we have used in our project. So out of these three models, there is a ResNet 50, Inception V3, and next slide, MobileNet. So we have like used these models in our project, and we got the most accuracy through our ResNet 50 model. So that's we have like prefer for our project. Next to the slide. So these are the output. So the input image we have given to our project, and then we got the output, which is almost similar. And this is the output from our data set. So there might be some like there were 5 images. Next slide. So these are here we can compare like how Resmi 50 gave more accuracy. Here we got the most similar images related to our input, and these are the inceptions output. Next slide. So here we can see like how much we got the accuracy through Resmi 50, and these are the different parameters. Next slide. Over to the Nikhil.
So what to take our project so that it looks unique. So we uh,
You are not audible.
Hello.
Your voice is
Uh,
breaking.
hello, hello. Am I audible?
Continue.
Hello.
Uh,
Uh, am I audible, sir, clearly?
so your voice is
Hello.
breaking a bit, but now you're audible, so you can continue.
Okay, ma'am. So we tried to add an extra feature in our recommendation system, which is virtual try-on. In this, user uploads their photo and chooses a piece of clothing which they want to try. And by using our AI model, which uses GAN, they can see how those piece of clothing would look on them. So to build this model, we have used GAN for generation of images, and the to uh, to train our model, we extract features like heat map and black and white images to train our model. And firstly, our accuracy was very low, like 40%. Then we increased the number of data set to 15,000. Then the accuracy was around 70%. We have not yet deployed our connected the recommendation system and virtual run in our website yet. Thank you.
Conclude your presentation.
So, sir, we have built a fashion recommendation system for e-commerce websites. Like, for example, like if they want to incorporate such things which is not describable, so they can use our systems, and by putting an image into that system, they will get the customer will get the product if it is available in their inventory. So this was our purpose and solution to the problem which we have faced in purchasing clothes and everything in sometimes. Uh, so yeah, this is the
Yeah, how you compare your existing how you compare existing work and with your work?
sorry, sir. Can you repeat?
How you compare the existing work with your work? So what is your contribution actually in this paper?
So
Uh,
we tried to add virtual tron in our project, which is not very feasible in a lot of clothing websites.
Okay.
Uh, and that was our key feature for this project. So that's what makes our project unique.
Okay, man. Siddhi ma'am, can you take next presentation?
Yes, sure. So the next paper is on efficient KYC for DAO using blockchain. And this paper will be presented by Manasa Desai from Siddhaganga Institute of Technology, India. Any of the co-authors from Manasa Desai's group, or if, if you are present, please start with your presentation. Because I don't think she has joined the meeting. Okay, we'll proceed to the next presenter. So the next paper is on enhanced safety stun gun with GPS and GSM for self-defense. And this paper will be presented by Chilakala Sudhamani from CMR Technical Campus, India. Anyone present of this paper title? She has also not joined the meeting. We'll proceed to the next one. So the next paper title is Familiar Faces, a novel approach to persona classification using facial recognition and digital footprints. This paper title will be presented by Swarup Vishwas from Vishwakarma Institute of Technology, India.
Hello.
I request Swarup Vishwas to proceed with your presentation.
Can you stop sharing the screen because I can't share the screen.
Now you will be able to share your screen.
Yeah. Okay, so is my screen visible?
Yes.
Okay, so good afternoon, everyone. My name is Swarup Vishwas, and I am here to present our research on familiar faces, a novel approach to persona classification using facial recognition and digital footprints. This work has been conducted under the guidance of Dr. Ganesh Budkar, with contributions from my co-authors Riddhi Sonamne, Akshay Shingote, and Vivek Badade, all from VIT. So these are the agenda that we are trying to cover in today's session. So, in today's digital world, user persona play a crucial role in personalization, security, and user experience. With over 4.9 billion people actively using social media, vast amount of digital footprints remain underutilized. However, security concerns like identity fraud and unauthorized access are rising due to weak verification methods. To address these challenges, we introduced Familiar Faces, an AI-powered persona classification system integrating facial recognition and digital footprints to enable real-time adaptive user modeling. To build our approach, we reviewed key research in persona classification and facial recognition. For example, one of the paper was focused on creating a password management system password management system with a facial recognition based verification system. So it tried to create a 95% of accuracy. The only issue was that it was not a very as clear as uh, in a high lighting as it was in low lighting. So that was one of the paper. There was also one of the other paper which was only on persona study, which was done by a survey in an hospital here in Pune, and it was basically on the pregnant ladies who were at the early stage of after delivery. So that was what the paper was about, and they tried to identify the key user behaviors about it. Then there were LLM-based persona synthesis, which was helpful for identifying the various diversity in personas. As the survey, for example, in the previous study was focused only in one hospital in Pune, so there were not a lot of diversity. But if we want to find a diversity, we can use a models like LLM. That's what they tried to tell. But LLM do hallucinate, and that was the limitation of the paper. Then there were other two papers that helped to find a social media data analysis, which we tried to inculcate in our project. And the behavioral based personas and real time person adaptation were done with only uh, scalability and lacked qualitative validation were the only limitation of these papers. So after we found out what the problems were, then what the limitations are, and finding out what we can build, we tried to just create a basic diagram, or we tried to create a software develop as you know SDLC life cycle. There should be a use case diagram. So we divided the persona into three different types. First one is social butterfly, then there is the academic persona, then there is social gym freak persona. So as we wanted we needed to create a data set of our own, and we needed the and we had the data set in our college. Like we have a real human being, and we can take a data set by using surveys and everything, and the social media handlers. So the major age group was between 19 to 21. And when we tried to, when we gathered the data, that these were the three main user personas categories that we found out. So social butterfly, which will be extroverted. Then there will be academic persona, which are rather introverted, and they will uh, try to go to the. They won't be. They can also be an extroverted academic persona. For example, the people who likes to go to the meetups, who like to meet a new people, but not for the social gatherings, but to get an knowledge, to get a knowledge. Also, there are gym freak persona who are rather sensitive about their fitness, what they eat and what they not. So these were the three types, and we try to find out various functions about them using, and these are the key points for how to classify. For example, event recommendation, if anyone is registered to the various events and or not. So accordingly, we will divide the persona into the three different categories. So after this, there was a system architecture. There are four main input. First one is spatial features. Her cascade classifier was used for that. Then there is a web scraping for LinkedIn. Then there is a Twitter. So Twitter had a Tweety API, but we also kept the web scraping. And then there is a GitHub official API, which will give us a GitHub data. As I told you that most of the students were from our college, most of the samples were from our college, and GitHub is one of the prominent platform in this age. So we try to build it in our database. Then there will be background screening, like there are various government APIs. Then the processing will be done. Image processing will be done. Then data segregation will be done. Sentiment analysis about how the user is and what is the mood of the user for finding out if he is more turbulent or if he is more assertive. Then there will be avatar generation with the facial features, semantic labeling of the data will be done, and then the persona will be classified into, as I told you in the previous slide, that there are three persona types that will be classified using KNN. So this is a facial recognition accuracy table. In indoor and outdoor, we have 100% of accuracy. In outdoor and in night, there is 66% as per the face detected. Then there is a crowded scene, which is 80%. Low light condition had 80%, and then HDR effect is it gives us a more little bit control over the that type of camera gives us control towards lighting and brightness, also darkness, about how the input photo can be and making it more clearer, hence giving us 100% accuracy there also. So this is the result. This is sample result. As you know, the Myers-Briggs type indicator, that is a system personality test if you have ever given it. So there is ENTP, there is INTP, there is ENTF, ENTJ, and that kind of personality traits are there for each and every person. Um, that's what we tried to find out. As we told in the previous, that there is sentiment analysis. So this were done for introvert or extrovert, creative or analytics, thinking or feeling, which is assertive or which means assertive or turbulent. Feelings means he takes decision making as a more towards feeling and less towards thinking. Then there is sensing and intuition, judging, perceiving, avoids risks, takes the risk. Everything will be gathered through the sentiment.
Hello.
Yeah, yeah. Hello.
Actually, we passed the presentation time. Can we please get to the conclusion?
Yeah, yeah. It's done. It is okay. These are the use cases. For example, one of them is a recruitment analysis. And as concluding the presentation, to summarize, familiar faces leverages facial recognition and digital footprint analysis to create dynamic real-time persona. It enhances security, personalizes user experience, and ensures privacy compliance to adhere to data protection regulations like the PDP Act. And our approach bridges the gap between technology and human behavior, paving the role for smarter, adaptive digital ecosystem across industries. Thank you for your time. I would love to hear your thoughts and answer any question you may have. Thank you.
Okay, Swaroop, nice presentation. I just want to ask you, if there are some images that covered the faces that are covered by the mask. So in case, how your the algorithms that will react?
Well, actually, the classifier that we are using has classified a full frontal classifier. So, if we want an higher accuracy, we will need to take some like if there is a mask, there is also object detection. If mask is found, they're going to give an alert that okay, that's you are covering your face or anything, and accordingly, then they need to remove it because we can't just give our private data to a person who cannot even give us an identity, if you know what I mean.
Okay, how your research work that will focus on AI biasness and reducing the false rejection?
Okay, so the biasness, as this was for only student data, like 19 to 21 years old. Uh, when we were creating database, we also had a surveys side by side. So the data, so the model which was trained, the KNN which was trained was not only on the social media but also on surveys. So that gives us an opportunity that there won't be a more false positive as expected.
Okay,
Yeah, thank you.
that's it from my side.
Thank you, sir, for your presentation. Now we'll go to the next presenter. So the next paper is on Green IT, exploring sustainable technologies for reducing the carbon footprint of IT operations. And this paper title will be presented by Afia Anjum Abdul Rafiq from Datta Mega Institute of Higher Education and Research. I request Afia ma'am to start with your presentation.
Good afternoon, everyone. I'm audible.
Yes, ma'am, you're audible and we can see your screen. You may start with your presentation.
Okay, ma'am. This is Afi Anjum Abdurrafiq from Datta Mega Institute of Higher Education, and today's my research topic is the Green IT exploring sustainable technologies for reducing the carbon footprint of IT operations. And my co-authors are Martin Maule and Dr. Shailesh Gahani sir, Deepak Sharma sir, and Dr. Pankaj Kumar Anavade sir. The table content of my research is introduction, research methodology, literature review, IT operations, challenges, and best practice for the reducing the carbon footprint, improving the efficiency, conclusion, and references. Introduction of the my research paper is that digitization process transformed the sector of global industries, making all things easier and faster with the capability to experience unheard of growth. However, the digitalization has brought about its cost. IT operation with the data centers, servers, and networks infrastructure that are being maintained and have become a heavy source of carbon emission for the global world. The research methodology for the title Green IT Exploring Sustainable Technologies for Reducing the Carbon Footprint of IT Operations is based on a review of secondary data. This includes a collection of relevant information that is readily available in the published literature, which could be academic journals, reports from various industries, corporate sustainability, publication, government documents, and reports released by NGOs. Literature review, the impact and mechanism behind the effect of a digital economic on industrial carbon emission reduction. BAZU 2024 exhibits several significant contributions towards understanding how digital technologies could influence industrial carbon emissions. The another literature review is in the paper title, The Role of IT in Sustainable Environmental Management, a Global Perspective Review, make a several significant contribution towards understanding how information technology can support achieving the goals of sustainable environment and management. IT operation environmental impacts. The first one is the energy consumption, second one is resource exhaustion, and the third one is electronic e-waste. Energy consumption data enters for the infrastructure for cloud computing website and enterprise application. application, and they are the most significant contributors to energy consumption in IT operation. Resource exhaustion: IT hardware relies on the extraction of raw material such as rare earth metals, copper, aluminium to assemble personal computers, servers, and networking equipment. Electronic e-waste: another crucial issue that follows IT operation is e-waste. Devices become obsolete and their obsolescence lead to several devices being dumped, which is contributing to this problem of global electronic waste. Challenges of the green IT is first one is unfamiliarity and education regarding green IT, technical limitation, policy and regulatory barriers, and cost constraints. Many organizations need to work on a financial challenges after adopting green IT. Energy efficient hardware and green equipment are also capital intensive, and renewable challenges in implementing green IT is cost constraint, unfamiliarity, and education regarding green IT. Technical limitation: while significant gain is sustainable technologies are on the cards, most of the solutions are still in nascent stages. For example, renewable sources of energy might decrease the carbon footprint of the data center, but they predominantly suffer from an intermittent source of power, making it less reliable. Best practices for the reducing the carbon footprint of IT operations. Although it may not be possible to achieve a utterly sustainable IT operation, organizers can take many practices steps towards minimizing the carbon footprint. The best practices that can be adopted in the management of energy include optimum cooling of the data centers, uses of renewable sources of power, and elimination of energy wastage. Improving the efficiency of data centers, consolidation of servers. The saving of energy consumption through virtualization and cloud computing arises from a decrease in the need to host a server physically. These technologies optimize resource utilization because they can host more than one virtual server on one machine, thereby significantly lowering power usage. The conclusion of my research is the green IT is an essential opportunity for the IT sector to reduce its impact on our environment and contribute positively to the global success in meeting sustainable goals. However, despite the opportunity that may arise from the embarrassing green IT, such as cost saving, there are challenges in its adoption, include cost constraints and what is currently possible with the technologies and awareness. This will be met with the joint efforts from business, governments, and the IT community, as well as education toward policy, reform, and innovation in sustainable solution in IT. And these are the references of my research. Thank you, sir.
Okay. So what are the different challenges that were mentioned? So which one is the major challenges actually that stop the that the green IT to become green IT or to get a green IT solutions?
Oh, so one of the biggest challenge is the policy regulation barrier because if government bodies engage the people around like the IT companies to actually maintain how this regulation can be applied. This can enhance the government's effort to stop the carbon footprint from uh, affected people.
Okay. Okay, that's it from us.
Thank you, sir. Now we'll go on to the next presenter. Now, the next paper title is Multi-Scale Forecasting of Electricity Demand in Telangana Using Time Series and Machine Learning Models. And this paper will be presented by Shrishta Miana from Chaitanya Bharati Institute of Technology, India. I request Shrishta ma'am to continue with your presentation.
Yeah, can you allow? Yeah, just a moment.
Yes.
Can you see my screen?
Yes, ma'am. Your screen is visible.
Yes. A very good afternoon to all the panel members and my fellow presenters. So I'm Shrestha and I'm from Chaitanya Bharati Institute of Technology, Hyderabad. So today I'm gonna present on the topic multi-scale forecasting on electricity demand for Telangana using time series and machine learning models. So this is the flow we are going to follow for today's presentation. We are going to cover the introduction, the objective, the models used, the methodology, the comparison with all the models we've used to get the final conclusion, the results overview, and the conclusion. So our we've initially started to tackle the problem statement that the Telangana state is currently suffering from financial burden uh, due to inaccurate forecast in the electricity board. So what is happening is that whenever the electricity board wants to purchase electricity for the consumers for the upcoming 5 years, they purchase electricity from the private sectors or the central government. For this purchasing, they estimate the consumption uh, for the next 5 years using a traditional method called as CAGR method, which is the compound annual growth rate. So what happens when they use this method is that they'll be unable to capture the uh, seasonal seasonal demands or the peak time demands. So we've come up with a solution of using time series forecasting models, that is ARIMA, Profit, WMA, and ETS models. And to make the forecasting more accurate and to capture more complex patterns, we've also used advanced machine learning models like LSTM and GBM2. And we've used the evaluation metrics like RMSE, MAPE, and MAE to evaluate the accuracy of these models. So due to rapid increase in the state's demand for electricity, it's very tough to capture what's the exact requirement for electricity. So we've come up with a solution to produce the multicast forecasting models. That is, we will be able to forecast the yearly, monthly, weekly, and daily demands too for solving the issue. So we've used LSTM and GBM as base models, and the WMA, ARIMA, ETS, and Profit for the time for the forecasting models. So the objective for our project was to develop an accurate and scalable multicast forecasting framework for the Telangana state, and to also provide sector-wise consumption analysis. That is, for different sectors, we provide the consumption forecast analysis for agriculture, for domestic, for commercial, and each and every sector that's in the state. And through this, we will be able to optimize the power management and the cost efficiency with state too. And for this, we've used the ARIMA model, which is the best for capturing seasonal accuracy. The seasonal ARIMA model is best for capturing the seasonal accuracy for yearly and monthly patterns. And Profit works well for additive. Profit is an additive time series model, so it performs well for seasonal and cyclic variations too. Whereas WMA model, it works best for the short term accuracy. It captures the data from the recent observations and gives the output. ETS works the best for weekly and monthly intervals. That is the short-term intervals, not long-term. And LSTM works the best for remembering long periods of data. So we've come up with a conclusion that no single model performs the best for this. So we've come up with an approach of using a hybrid model for our project. That is, we've used LSTM as a base model and ARIMA and WMA for accurate forecasting. So for the data collection, we've collected the data from a Telangana open source data, which has the data of each and every sector: agricultural, commercial, residential, cottage industries, and each and every sector that the state provides electricity to. And we've had the columns like the year, month, uh, what's the consumption, what are the overall sales for that category. And for we there was a that was a huge data, and so we had to handle the missing values, normalize the data, and perform time series data for every month by adding the monthly data. And we've also developed the LSTM and GBM models to capture the complex patterns in the data. We've used the metrics like MAE, MAPE, and RMSE for evaluating our data. So our project aims to capture the long-term consumption for the state. That is the yearly, that is the 5 years for the upcoming 5 years. That is, we need to predict the data for every year for the upcoming 5 years. The existing papers we've studied, they weren't able to capture this, that is the yearly data. Some were able to capture the monthly and everything, but we were able to get the solution for yearly consumption data. So this is the comparison of the models, ARIMA, ETS, WMA, and Profit. And we come to a conclusion that Profit performs the best for all sectors, especially due to the seasonal variations in the state. And ETS WMA and seasonal ARIMA, even though they perform well for short-term demands, they don't perform well for long-term demands. So this is our model architecture. This is how it goes. We've collected data from Open Data and SLDC data, which is the State Load Dispatch Center. And we processed the data. We forecasted it separately for the forecasting models and ML models. And finally, we've evaluated those. And this is a results overview, final results overview. The LSTM ARIMA Profit hybrid model performs the best for this case. MAP has a lower accuracy, which is a very good thing, an accuracy of 4.8%, or RMSE and MAE have values ranging near 20 megawatts, which is a good thing. And these are the hardware and software requirements, which is we've used Python. Yeah.
Sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Yeah, sure. So we've finally come to the conclusion that a hybrid approach combining LSTM with ARIMA and Profit gives the best results in this case. And it also enhances the grid management, the peak load forecasting, and cost efficiency. And it's adaptable to the state's existing framework too. Thank you.
Thank you, ma'am. Are there any questions?
Yeah, Shrestha, in your data set, what are the factors that were considered for the electricity consumption? And
Sir, we've had a column representing the sales of each and every month. So our data set was like, there was a month column, there was an year column, there was a lot of columns and a sales column. So for each and every month and the sales, we've matched those, and we were able to get the forecasts.
so you mean the electrical vehicle charging factors or electricity consumption also considered in that data set?
Yes, sir. But in the current state, those EV charging stations are very low. So there is data, but there's negligible data compared to other sectors like agriculture, domestic, and commercial, which are the highest usage in any state.
Okay.
Yes, sir.
So this project is designed to specific state only by considering the data from that particular state only, right?
So
or it could be applied this model. It could be applied to
it can be applied to other states also, because we've considered the data set from the Telangana open data. We've used this data set to tackle the challenges of peak demand in this data, but the factors of this state might be different from other states.
Yeah, right, exactly.
Yes.
So it could not be a generalized model, right?
No, sir. There's a bigger issue in the Telangana state. That is, the agriculture sector doesn't have metered data. So the open data, whatever the state has, that might not be accurate. So that doesn't work for other states too.
Yeah, you can extend your project using the transfer learning so that it can easily transfer on any data set to get the results of, we can say that the data set from any particular state. So using the transfer learning model, yeah, they can easily train the model and they can be used for any state to give the results.
Okay, sir, sure.
Yeah,
We'll do that for the future scope. For
yeah,
now, this was the scope we could perform a project on.
yeah, it was good. Yeah,
Yeah. Thank you, sir.
yeah.
Hello. Thank you, ma'am, for the presentation. Now we'll go on to the next presenter. So the next paper title is Predictive Modeling of Childhood Fever Prevalence, Leveraging Machine Learning in Maternal and Child Health. And this paper would be presented by Hemal ES from Dayananda Sagar University, India. I request Hemal sir to please start with your presentation if you're present in the meeting or any of the co-authors. I think he's not there in the meeting. The next presenter is the paper title is Visionary Assistance where Smart Outsmarts Site. And this paper would be presented by Shivam Kumar Singh from SIM Institute of Science and Technology, India. I
Hello
request
everyone.
Shivam sir.
I'm sharing. Does my screen is visible?
Yes, sir.
Good afternoon, everyone. My paper title is Visionary Assistant where the smart outsmart side. So me and my co-authors are present in the team. So myself, Shivam Kumar Singh. Currently, I'm in the final year student in the SRM Institute of Science and Technology. So this is basically about the minor project paper where we have our objective is to develop a low cost portable IoT devices which can able to real time identify the object, recognize the test, face identification, and we are working it to be like enhancing the facility so it can be mobility and also help the visually impaired person to uh, go from one place to another place. So in this, we have uses the various modules. For example, first is the GPS module, which help us to get the person's location, live location, where we have compared the GPS module available, and we have used the new 6M GPS module for the GPS monitoring, and then we have the ear camera system for the identification of object and all. So here we have the different cameras. In respect to the minimum cost, we have chosen the ESP32 camera, which provide the Wi-Fi, Bluetooth, and the low power support, and also the AI power support. So we have chosen this. And in the computer vision model, there are the many models. So we have using the HAR cascade for the face recognition and Tesseract OCR for the test reading and MobileNet SSD for the object detection because its speed is also high and it compatible to the ESP32, which is our base model for the system. So this is our the flow. So this is our flow where this is our flow. The first is like the video will start captured, and user will going to discuss like what is happening here. Using the ESP32 camera here, we can see the ESP32 camera is gathered here. So it will capture the images, and also it will going to describe what the scenario is going to happen in that, like in the surrounding what is happening. And you can see here the Arduino is there, which help us to tell like. Arduino used as a main board through which communication is going to be happen. Next thing is like IoT parts, which helps to give the signals like the object detection and also like the GPS module things. And this is the face detection also like which helps to detect the faces of the object, like the faces of the human beings which is present here. And this is our full-fledged IoT devices where the person can read whatever written in there. And this is the device which we are going to further integrate for the major project. And this is all about my project, my paper in the project.
Okay. What are the challenges while deploying this model?
The thing is like the while deploying the model, many supports are not there. For example, in ESP, the many we does not get the proper support from the forums, and while deploying each other in one same component. For example, like integrating the Arduino with the ESP camera, integrating with the GPS module, and integrating with other IoT devices, there are no much support. So we have to integrate with by on knowledge and all the things. So it takes a lot of time to integrate all into a one devices, and also it's like a very small devices. So we need to handle with the care, and also we need to take care of wiring and everything. Otherwise, it will be our IoT devices will be burned out.
What would be the actually cost that is required to prepare this the IoT based?
The cost is around we have invested around 1,500 to 2,000. So the pre-existing market have around $100 the same thing. So we have developed the same thing in the 1,500 to 2,000 rupees Indian rupees. But in the pre-existing market, there are around $100 to $1,000 devices are available.
Okay.
Can I stop sharing my screen?
Yes, that's it from my side.
Thank you.
Thank you, sir, for your presentation. Again, I want to call out this paper titled Enhanced Safety Stun Gun with GPS and GSM for Self-Defense would be presented by Chilakala Sudhamai from SMR Technical Campus. I think one of the co-authors is present in the meeting and they would like to present the paper.
Yes.
Okay, ma'am,
Good
you can start
afternoon.
with the presentation. I'll
Okay.
stop sharing this.
Myself, Spurti, and I'm currently in third year from CMR Technical Campus, and the research paper is on enhanced safety stun gun with GPS and GSM for self-defense. These are the contents. Firstly, abstract. In today's global scenario, women are facing numerous challenges, uh, like average, in an about average, 87 women are facing daily problems, atrocities, harassment, and molestation. To overcome this problem, we have proposed a device. Firstly, these are the existing systems, personal alarm, keychains, and pepper spray, which can sometimes it is not possible to overcome in that situation. It is not helpful. This is the proposed system. We have used Arduino and GPS and GSM module. Uh, Firstly, we have two buttons, taser button and a panic button. By pressing taser button, it gives a shock voltage of it goes increasing more than till 1,000 volts. And by pressing panic button, it will give a text message that latitude and longitude, so that we can copy that latitude and longitude and we can know the location of the person who are in dangerous situation. And also it makes a call to the pre-selected numbers in the code. These are the results that the text will send to the pre-selected numbers that I am in danger location at latitude and longitude, and also it produces a shock. And that's it. Thank you.
Okay. Yes. Yes, Purti, it was a very short presentation. It's okay. I would like to ask one question. So in case of sending the message, right?
Yes, sir.
So in somewhere the situation is like that, there is no any network, any kind of the network, and unable to deliver the message. So what in that case actually what else the techniques yes you can integrate in your system.
Actually, if there is no network, it is not possible to send a text or make a call. For that, we need to work. It is the future scope. We are working on it, and but we have also included that shock circuit so that for some time we can delay the or escape the situation. That's it.
Okay, okay, that's it from my side.
Fine.
Thank you, sir. Thank you, ma'am. Now, before proceeding to the closing remarks, I would like to call out the names which were people. Yes. Okay. So efficient KYC for DIO using blockchain would be presented by Manasa Desai. If any of the co-authors is present in the meeting, let's start with your presentation now, or else we'll proceed to the closing remarks. This is one paper, and predictive modeling of childhood fever prevalence, leveraging ML in maternal and child health by Hemal from Dayanand Sagar University. If he is also not there, then we'll proceed to the closing remarks.
Yeah, thank you, madam. I hope all the papers are over. Good afternoon, everyone. So it has been a privilege and honor to serve as the session chair for this segment of 9th International Conference on Smart Trends in Computing and Communications. I extend my heartfelt congratulations to all the presenters for their outstanding contributions. Your work reflects not only deep expertise but also immense dedication to advancing the fields. The presentation today covered the different fields, including artificial intelligence, Internet of Things, data analytics, which showcasing the innovative and transformative research happening in smart computing and the communications. And these insights highlights technology potentials to address the real world challenges and shape the futures. I also want to express my gratitude to the organizers for creating this platform for collaboration and intellectual exchange, and to the audience for your active participation and thoughtful discussion. Thank you once again for your valuable contributions. Let's continue working together to innovate, collaborate, and push the boundaries of what is possible in the exciting field. Thank you once again.
Thank you so much, sir, for your kind words. Lastly, I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. Lastly, I have some instructions. All the presenters would be getting their digital certificate via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SmartCom 2025. And thank you so much, Dr. Supan sir, for chairing this session.
Thank you, madam.
Just a second. A token of appreciation to the chair on the behalf of Team SmartCom 2025. Thank you for your valuable presence. Now, just before we end this meeting, I request all the participants to please turn on your cameras so that I can take a quick snapshot and end this meeting on a good note.
Hello?
Okay, I've taken the snapshot now.
Hello? Excuse me?
Hello.
I'm really sorry. My name is Hemal, and is my presentation done?
Yes, you were one of the participants, presenters, but I think we can have his presentation right now, right? We were about to end the session.
Yeah, I'm sorry. I thought it was 2:15. I'm really sorry.
No, it was supposed to end at 2:50.
Okay, I'm
You were
sorry. I'm sorry.
one of the second last presenters. But I
Oh,
guess we can have your presentation.
okay. Yeah, that will be nice. Thank you. Is my screen visible?
Yes, sir.
Okay. Good afternoon to all the judges and the others present here in this meeting. My name is Hemal, and we have written a research paper on predictive modeling of childhood fever prevalence, leveraging machine learning in maternal and healthcare. And I'm from Dayanand Sagar University, located in Bangalore. So, introduction. Childhood fever is a major health concern in India. Childhood fever is the most common reason for pediatric hospitals visit in India. Many parents, over 30% of the children born frequently visit pediatric hospitals in India. It can be caused due to infections that can be caused by viruses, bacteria, and parasites. And it even depends on environmental factors such as the weather. Babies tend to fall sick when it's cold, and underlying health conditions. That is, if the baby was born underweight or something. If untreated, it can lead to severe complications like dehydration, seizures, or life-threatening infections like meningitis. The challenges faced right now by the most of the hospitals. Unequal healthcare infrastructure is basically the difference between the difference in the healthcare infrastructure in the urban and the rural areas. In urban areas, the healthcare infrastructure is very highly available to everyone, whereas in rural areas, it's really hard for the people to go access the medical infrastructure. And inadequate medical records, many cases go unreported due to its insufficient medical infrastructure, particularly in rural remote areas. And late diagnosis. Lack of awareness among caregivers often lead to delayed detection of fever, increasing the risk of complications. So the objectives of our research paper is we developed a systematic machine learning model to predict childhood fever prevalence. And we used many healthcare indicators like antenatal healthcare, immunization, and nutrition. This model is basically a early detection model that will help healthcare professionals to take preventive actions, and it also helps improve the health outcomes of infants by enabling timely intervention and better resource allocation. Yeah, so the literature survey. So we went through a lot of survey papers, and these are some of them. First one is the neonatal mortality prediction. So basically, this paper they used the XGBoost algorithm and the CNN algorithm to predict the mortality rate in neonatal babies. So then they achieved accuracy of 94%. So, and then the second paper is about fetal disease classification. They again used XGBoost algorithm, and they achieved an accuracy of 99%. And then the third paper is about low birth weight prediction. And then this paper used random forest algorithm and identified key maternal factors with accuracy of 91.6%. And the last paper was neonatal jaundice detection. They used XGBoost and CNN to basically find the look at the color of the eyes. Basically, people with jaundice tend to have yellow colored eyes. So they used a webcam based system and CNN algorithms to predict the jaundice, to detect jaundice, and they achieved a accuracy of 99%. So these studies show that ML models provide high accuracy in predicting childhood health issues.
Inspired by these findings, our study uses support vector regression algorithm to predict childhood fever prevalence based on maternal and healthcare indicators. So this is the workflow diagram of our prediction model. So the first one is data acquisition and pre-processing. We got several data sets from Kaggle. Each data set containing data, there are many data sets in the file. Each data set consists of data about one topic. That is, if the data set is about delivery care, the data set will contain the features in the data set will completely be about the information related to the delivery of the baby. That is, if it was delivered in a government hospital or if it was delivered in a private hospital or at home. Similarly, we have data sets containing information about immunization and vaccinations. All these features in all these different data sets are then merged together. That is in the data acquisition and pre-processing stage. In the feature selection stage, we load all the merged features to a variable, and then we set the target variable. Here, the target variable is going to be total children suffering from fever. In the data splitting stage, we used 80% of the data for training purposes and 20% of the data for testing purposes. And then in the model selection phase, so in our implementation paper is about, there are two objectives. One is determining the best algorithm used to select the features. And then the objective is to list out the best features that can be used to predict fever in babies. So in the model selection, we used the data set and trained around 10 algorithms. And then the best algorithm was found out to be support vector regression. I'll show you in the results phase how we found that out. And then in the model evaluation stage, we find out the mean squared error, the mean average error, and R-square score for each algorithm. So MSE ensures mean square error ensures the larger errors have larger penalties. Mean average error ensures the average magnitude of errors. And R square tells us how well a machine learning model's prediction matches the actual values. So since among the 10 algorithms that we used, the best one was support vector regression. That algorithm had the least of all these among the three metrics that we used, the best performing was support vector regression. So what support vector regression does is it will basically give coefficients up to each and every feature in the dataset. So in the dataset we took 40 features. So the support vector regression algorithm gives coefficients to each and every feature. So the coefficient will basically represent how much change is made to the target variable if there is any change in the feature. So a feature with a higher coefficient means the impact on the target variable will be higher. And if the coefficient value is smaller, that means its influence on the target variable will be lesser. So that is how we found out that support vector regression algorithm was the best algorithm among the 10. I will show you all the algorithms that we used in the following slides. And then the final stage is the feature importance analysis. So in this stage, we use the coefficient values that the model gives to each feature and then rank them in descending order based on the importance. And then we also plot it in a graph. So the result, this is the feature ranking of the 40. We used 39 features, and this is the ranking of all of them in descending order. So I will show you the top 5 ranks. Among the top 5 ranks, the first rank goes to the feature which represents the total number of children aged between 6 to 35 who received at least 1 dose of vitamin A during the last 6 months. So this feature was the most important feature. This most important feature among the 39 features, which can help us detect fever in babies. Rank 2 indicates the total number of mothers who stayed in the healthcare institution for less than 24 hours after delivery. Rank 3 represents the total number of mothers whose blood samples were taken to check their hemoglobin levels. Rank 4 indicates the total number of newborn babies who received a checkup within 24 hours. And rank 5 represents the average month at which children received food, especially vegetables and fruits instead of breast milk. So these were the top 5 ranks among the 39 ranks that I showed you in the graph here. And as I told you, we used around 10 algorithms. In the graph, you can see in the x-axis, we used SVR, ridge, logistic, gradient boosting, etc. Among them, we calculated for all these algorithms, we calculated the mean square error, mean absolute error, and R square score to determine the performance and rank them from worst to best. So as you can see in the graph, support vector regression is ranked first. This is the descending order of the ranking, and support vector regression emerged as the top performing algorithm, showcasing its robustness in capturing complex relationships between variables. So yes, the future scope about with our implementation is we can integrate it using real-time data. So we can gather real-time data from hospitals and government records.
Sorry for the interruption, sir, but we are past the presentation time. Can you please get to the conclusion?
Yeah, sure. So yeah, I can conclude by saying that this project demonstrates the effectiveness of machine learning, especially the support vector regression and predicting childhood fever prevalence in India. So the key factors, we also found out the top 5 features which people have to take care of while determining to prevent fever in babies. Future research can enhance predictive accuracy by integrating socioeconomic and environmental factors. So we can also use in the future, we can also use deep learning models to work with large amounts of data. So yes, these are references, and yeah, thank you.
Thank you, sir. Thank you for your presentation. Are there any questions?
Yeah, Hemal, I just want to ask you, what is the impact of data on the performance of the algorithms?
Sir, I didn't get your question. Can you elaborate a little?
Yeah, so what is the impact of data? So whatever the data set that were used here, yeah, different machine learning algorithm and data set that were used, right? So what is the impact of it on the performance of the data, on the performance of the algorithm?
Okay, so the data set, the data set basically it consists data about mothers and their children of every single state and city in India. It consists data of about 300 cities in India. Basically, there are over 4,000 cities in India, but then the 300 cities have only 300 cities have more than 1 lakh people. So we took 300 cities, and then every single important feature is there in the data set. For example, it can be the vaccination and immunization data, and then even baby birth. I mean, the hospital data and everything is there in the data set. So it can be effectively used to determine fever. There are many other features. Would you like to see those data, sir?
Yeah, how to perform the validation of algorithm, any algorithms?
Sir, what?
How to perform the validation of any algorithm? Means,
Yes.
yeah.
Yeah, go ahead, sir. What were you saying?
Validation about your algorithms means the accuracy, we can say that.
Yes, sir. So basically, our accuracy, what we calculated is the mean squared error, mean absolute error, and the R squared values. So mean squared error, as you know, it is basically the ensures that larger errors have larger penalties. So as you can see in the graph, the blue line indicates mean square error. So since the SVR has the lowest error among the others, it is plotted at the lowest level. Whereas the worst performing algorithm is a polynomial algorithm, which has a very high error. That's why it has been penalized a lot, and then it has been plotted on top of the on top of the graph. Similarly, mean absolute error and the R squared error are almost similar for all the algorithms except for the polynomial algorithm.
Got it, sir. Got it. Yeah.
Yes.
Hello.
Yes, ma'am.
Okay, so thank you, sir, for your presentation.
Thank you.
Now, before ending, we have one more presenter.
I would like to say I'm really sorry for coming late, and then really thankful for you to giving me the opportunity to presenting it right now at this time.
It's all right.
So
It's
thank
not.
you.
It's
Thank you so
not an
much.
issue.
Thank you.
Thank you, sir. Now, just before we end this session, actually, there's one more presenter. Since we have a slot, we can take his presentation. So the next paper title would be presented by Mr. Murugendra Singh
Yes, ma'am.
Rahiwar. Sir, could you please start with your presentation?
Just a minute. Screen is visible to all.
Yes.
Okay. Okay, thank you for allowing the presentation. Due to some medical emergency to the one of my co-author who is going to present this paper. Okay, so he's not able to present, so I need to join. So the our paper ID is 39 and the topic is in the agriculture area there is one crop which is in cassava, and we want to find out the disease in that particular cassava using the deep learning techniques. Okay, so for that we are using the hybrid approach of the different layers of the stacks, and we integrate the our models with the pre-trained models. Okay, to enhance the feature extraction, so which will detect the disease in a much better way, and which helps the farmers on the early detections. So basically this is the outline, and the main part is the farmer are facing an issue when they go for the cropping at the same moment of time. If the disease are not detected in an early stage, then the farmers have the big loss. Okay, so this particular problem challenge is available on the Kaggle, and we participated in the Kaggle challenge with the same approach. So basically, the crop losses, and particularly in the agriculture area, that is because of the disease, as well as there is a lot of issue in the soil, like the moisture issue, as well as the CO2 issue, and because of that, the plants disease are growing in the market. So over the globe, around the 20 to 40% of the crops are losses just because of the disease. So particularly in the cassava, the this particular cropping is done over the globe. Around the 800 million peoples are doing the cassava farming, and there are different ways of the growing the particular crop is there. But like, suppose, is there any disease available or not? If we are able to detect in early stage, then it benefit to the farmer. So here we are proposing our approach. We go with the stack convolution neural networks and combine with the pre-trained models to enhance the feature which will benefit to the convolution neural network. So this is our proposed architecture. So when we feed an image, and then after we are applying the data preparations, like in the preparations, we need to go for the bounding boxing. We need to for the labelings of the data after the bounding box, as well as we are applying the data augmentations techniques to increase the size of the data. So at the end, the deep learning models will get benefits and
Sorry
get
for
an
the interruption. Sir, are you in presenting mode? There is a presentation.
yes, ma'am. Yes, sir. I am in the presenting mode.
Okay, but we are unable to see the presentation. See your presentation.
Okay. I'll again go for the presentation mode. Now this is visible. This is an architecture side.
No, there is some one paper that you are actually showing. One paper.
Okay, I'll reshare this, the same paper which we have already worked. Okay, I'll stop the sharing and reshare it again. Sir, now it's visible.
Yes. Just make it slideshow. Yeah, continue,
Okay.
sir.
Okay, thank you, sir. So this is an architecture where we are feeding an image, and during the data preparations we are applying the because there when the pictures are taken. Okay, so in the Kaggle they have not provided the data in a proper way, so we go for the cropping techniques, and sorry, we relabel the whole the data Then after we apply the data augmentation techniques because we want to go for the large scale of data. So where we apply the scale in, scale out, zoom in, zoom out, and the angling of the different like the 45 angles, 90 angles. Okay. Then after we also go for the coloring image converted into an grayscale image also. So there are, and then we also apply the skewing the image at some horizontal skewing as well as the vertical skewing. So ultimately our main focus is we don't want to focus only on a front facing angle camera and a single image. For a particular image we apply the data augmentation, and for each image after applying the data augmentation we are generating around the 200 to 250 samples of the same image. So ultimately it leads to a different kind of the feature and which helps the deep learning technique. So that's the role of the data preparations. After the data preparation, our task is to get and feature extractions of all the images which we have feed and pre-process. So we get and all those features and all the important features are available. Over that particular feature, we build our own CNN layer, and which is a stack CNN layer. So we go up to this layer 3, and then after at the end we flatten the whole matrices and which will convert it into an number of features, and at the end we are able to classify whether that particular plant have some disease or not. So this is an architectures of that particular approach. So basically the data set which is available on the Kaggle, so there are total 5 labels are there. Out of that, the 4 labels are related to disease, and the last label which is related to the plant is healthy. So there are different number of images are available. Okay. So in such case, like suppose the CBB image having the around the 1,000 sample, while the CMD having around the 13,000 samples. So with the help of the data augmentation, we try to balance the data, and these are the original samples. Okay, so instead of that, we apply the cropping techniques where the diseases are available. In some cases where the unnecessary informations are, then we have to crop from the data. So unnecessary information, or we can say unwanted information or features, we don't want to process in the deep learning model. So we can provide an cost-effective solutions to the uh, uh, sorry, we can go with the cost effective solution, and we can reduce the inference time also. So around the original data will contains the 21,367 labels data, but after the data augmentation, it's almost the 3x. We increase it, and then after we apply the deep learning techniques. So when we apply the stack convolution neural networks hybrid with the RaisNet, so where these all are the input images are there, and during the trainings, okay, like suppose we go up to the epochs number 30. So during the training, we got an accuracy almost near to the 98-99%, around 10 to 15 epoch. But at the same moment, the testing accuracy is still not stable. So we increase our our epoch size, and we try at least the training and testing both the accuracy match at some levels. Okay, and we get and pretty good results during the.
Hello.
Yes.
Sir, sorry for the interruption, but we are past presentation time now. Could you please get to the conclusion?
Okay, fine. And this is then confusion matrix where all the classes are there, and we got almost the nearly we are able to classify all the images as a true labels. Only the few samples are there where we are not able to perform better. So the key findings here, in the conclusion is main focus is on the enhancing the features, and with those particular enhanced feature, we are applying the stack CNN, and with the help of this enhanced feature, we are able to perform the task in a cost effective manners, like without the feature enhancing, when we apply the stack CNN layer, almost it takes the around 7 to 8 hours for training the data, but after enhancing the feature will we are able to train our models around the 2.5 hours. Okay, so that's the one of the things which we have achieved. And additionally, we also focus on the scalability while increasing the data and early detections of the plants. Okay, so here we just conclude. This is the conclusion of our work, and these are the references which we used. Okay, and thank you so much.
Thank you, sir, for your presentation. Are there any questions?
Sir,
Yeah.
if there is a data set of different images and images is having the low quality images are there, and then how actually it impacts to with the performance of that algorithms.
Yeah. So, sir, while when we have the low quality images, so what we are doing during the data preparation, because this is then crucial for our approach. In the data preparations, we apply if the images are blurry, then we need to smoothen that particular image, and then after we need to feed into the neural network. So where the data preparations play a major role.
Okay. Yes, thank you, madam.
Thank you, sir, for the presentation and for the patience. Now, I've already taken the snapshot, but we have a few more participants which I've added right now. So I request all of you to please turn on your cameras once again. Okay. Thank you so much, everyone. Now we can end this session and I can end the meeting.